I had homework 11 problem number 1, part B and D. Part B is if AH is equal to H, or sorry, AH is equal to H, if and only if A is in H. So I proved, suppose AH is equal to H, then A is equal to AE, and that's from part A. That's in AH, and since AH is equal to H, then A is in H. We have to prove the other way now, so we assume that A is in H. Since H is closed, AH is a subset of H. Next, we want to assume that H is in H as well. This implies that A inverse H is in H, since H is a subgroup of G. Therefore, H is equal to EH, and we can just replace the identity with A inverse H. Using the associative property, we have A inverse H, and we know that that's in AH. So H is a subset of AH. And this implies that AH is equal to H. So therefore, AH is equal to H if and only if A is in H. And then for part D, we had AH is equal to BH if and only if A is in BH. So I'm going to prove this way first. Suppose that AH is in BH, or sorry, is equal to BH. Then A is equal to A times the identity, which is in AH from part A. And if A is in AH, that's equal to BH. This implies that A is in BH. And so then the other direction, we assume that A is in BH. Therefore, A is equal to BH, where H is in H, capital H. Therefore, AH is equal to BH times capital H. And then by the associative property, that's equal to B lowercase h uppercase h, which is equal to BH. And therefore, AH is equal to BH if and only if A is in BH. And that's it.